Alrighty. This video is going to be a quick crash course into the new Unity GUI system. So what we're going to be doing is we're going to be downloading and installing Unity 4.6 beta, and then we're going to be jumping into it and putting together a really simple demonstration project. Now, you guys could follow along if you want to, but it should be sufficient just to watch what I'm going to be putting together. The purpose of this video is to get you guys kind of, you know, a overview of how it is Unity expects you to be building GUIs now, because it's quite a fundamentally different way than we're used to with the immediate mode on GUI system. So I really wanted to show you guys just some really basic stuff. How do we create things like sliders and buttons, and how do we wire up events, just to get you guys kind of in the mood for working with this system, since it is such a huge shift. And in subsequent videos, we're going to be taking a look at each one of the individual components, line item by line item, checking out what we can do with them and all that great stuff. But again, I think it's really important to get a good feel for what we're going to be doing first before we dive into the specifics. So we will be talking a little bit about panels and canvases and Rect Transforms, but the really in-depth discussion is going to happen in later videos. So let's go ahead and get started. First thing you're going to want to do is grab the Unity 4.6 beta. Easiest way to do that is to jump over to unity3d.com. Click on this little guy right there, hit Get Unity 4.6 Beta, and in this video series I'm going to be using the Beta 18. If you're using the Beta 17, I believe pretty much everything should still work, but Beta 18 is the one I'm going to be using. So go ahead and download it for your operating system. And while it's downloading, let me go ahead and explain how you can go ahead and get two different installations of Unity on the same computer at the same time, because I think a lot of you guys already have a Unity installation that you really don't want to compromise while playing around with the beta, because especially if you have an application that's in production, you're gonna want to be able to maintain that application while you are learning how to use the new GUI system. So it's really basic process. All you have to do is tell it to install Unity to a different folder. It's not going to remove your old Unity installation unless it detects one inside of the folder that you are installing it to. I do want to really quickly point out, however, that you really need to install it as a sibling folder of the other Unity installation at the very least. So what do I mean by that? Well, if I go ahead and open up my program files x86 folder right over here, you'll notice that I have my Unity and my Unity 4.5. And so I installed them as siblings of each other. What I mean by that is, they're next to each other in the same parent. Because if you were to install a different Unity installation, for example, within the Unity folder itself, thinking that it won't conflict with the editor folder, you might run into issues. And these issues are outlined in the Unity manual. So be sure to not do that. If you're going to install two Unity installations side by side, make sure that you do them in separate folders entirely. So for example, as separate folders in your program files, separate folders that are across different hard drives, and so on and so on. It doesn't really matter where you put the other installation, as long as it's not anywhere inside of the previous installation. Anyway, once you do that, you will have two versions of Unity going side by side, and that should be what you want for playing with the new beta. So after installation, what I did was I just jumped into my Unity folder, jumped into my editor folder, and just grabbed the Unity exe and plopped it into my taskbar, which is what you see right here. So when I click on this Unity editor, I am opening up the Unity Beta 4.6 Beta 18. Alright, so you might want to pause the video if you're still installing, but if you're done, let's go ahead and jump right in and put together something really basic. Again, just really basic crash course stuff, not going in depth yet, but it should give you guys a good feel of what's to come. So I'm going to go ahead and open up Unity. I'm going to go ahead to create new project, and I'm just going to say new Unity project 3. Why not? Hit create. Name's not really going to matter. Okay, so we're in Unity. Everything should look pretty familiar at this point. So your first question might be, well, how do I start making a GUI? To start making a GUI, you're going to have to create what's called a canvas. Now, a canvas is kind of the parent of all GUI elements. All GUI elements must be parented to, or must be a descendant of, a canvas. So the canvas is what controls where the Unity GUI is going to be rendered in your scene. So to do that, I'm going to go up here to my hierarchy. I'm going to right-click anywhere inside of this blank space in my hierarchy. Open up this new little UI dropdown, and I'm going to click on Canvas. So you'll notice a couple cool things happened. First of all, we got an event system in addition to our canvas. We'll talk about that later. And then we got this canvas guy. And if I double click on this canvas guy, you'll notice he's really, really, really big. And the reason for this is canvases are actually described in pixels, where one unit corresponds to one pixel, which means that this canvas is going to be very big, because if you look right here on the right hand side, you'll notice it's 957 by 600. Now that measurement is in pixels, but when we view the canvas inside of our system, inside of our scene, we will see that rendered as units. So 1 pixel equals 1 unit, therefore we get this really, really massive canvas. As a quick example, I could go ahead and create a 3D cube and place it somewhere, like 0, 0, 0, and you can't even see that cube. You know, I would have to scale it up really, 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 really big just to make it even visible when I'm viewing the canvas like this. So I really wanted to point this out. Basically, that's why the canvas is so big. It's not a bug or an issue or anything like that. It doesn't really conflict with how we're going to go about building our GUIs. Position of the canvas in this case does not matter. Canvases can be created as different types, and those different types of canvases dictate where those canvases are going to be positioned in the screen. Well, this type of canvas, it doesn't matter where it's positioned. So positioning is irrelevant. It's going to be painted directly onto our main camera, regardless of where it's physically located. So that's another important aspect of this. Remember, you can't have multiple canvases, and we'll talk about that later. But again, the canvas is really just the root element of a GUI. So I'm going to go ahead and delete that cube, and let's start working with our canvas. What I'm going to do is I'm actually going to hop into 2D mode. And 2D mode is really handy when working with the Unity GUI system because it allows us to view our objects as an orthographic projection inside of our scene view, which is really handy when working with a predominantly 2D based GUI system. All right, so now that we've done that, let's go ahead and do something more fun, I guess, and that's create a panel. So let's right-click Canvas, go to UI, and hit Panel. Now we have a panel. So I didn't really talk about what the inspector looks like with the canvas because we're going to talk about these other fun things later. But now that we're in the panel, we'll start to notice a little bit of a common thread among everything that's parented to a canvas at some point. And that is our transform is replaced with this Rect Transform. So the Rect Transform is basically the new GUI's equivalent of a normal transform and allows us to do everything from scaling to rotation, but it also allows us to describe where this element should be positioned relative to his parents. And it allows us to do some really, really cool things. So you'll notice right here that the panel is actually filling the entire canvas. And if I went into the game view, you'll notice that as well. You'll notice though is while I change the dimensions of my game view, two things seem to happen. First, the size of the canvas changes. In this canvas mode, the size of the canvas is always going to be determined by the size of, or the resolution of the main camera, as you can see right here. As I change the resolution of the camera, so does the canvas size change. You'll also notice that the panel size changes as well, and that's because the panel is currently set to fill its parent being the canvas. So how do we change that behavior? How do we make it so, let's say I want the panel to be 200 pixels wide, and I want it to only be docked on the right-hand side of the screen, and I don't want it to resize. Well, that's really easy to do. We can come over here up to our Rect Transform. We can click this handy little square doohickey right there, and we can see all sorts of these preset Rect Transforms we can create. Now we can even create custom Rect Transforms and do some really neat things with that, but that's going to be something we'll discuss later. For now, what I want to accomplish is I want, again, this panel to be 200 pixels wide, and I want it to be docked on the right-hand side of the screen. So what I'm going to do is I'm going to click this. That preset right there will make the panel be on the right-hand side of the screen, basically. So you might be wondering, well, it doesn't look any different. But if I come over here to my game view and I stretch it to the left, look at that. Now it no longer is taking into consideration the width of the screen. So it looks like I'm about halfway there. You'll notice that it also doesn't stretch horizontally, which we'll address here as well. So let's address the stretching horizontally bit first. I'm going to come here, and I'm also going to click on stretch vertically, sorry. So we want left, and we want stretch right here. So this button right here, you see that we'll stretch vertically, and we want to be docked to the right-hand side. Now if we come over here and start expanding it, you'll notice that it does stretch, but there's still this padding in between the top and the bottom that we would like to get rid of. The easiest way to do that is actually to use a handy little trick with this anchor presets, and I'll reiterate this handy little trick later in case you guys are getting a little confused at all these new options. But if you hold down Alt and Shift and then click on this, you'll notice that it'll expand to fit the entirety of the vertical space, which now our panel will behave almost exactly how we want it to. You'll notice that it's stuck to the right-hand side, it doesn't change its width, and it always fills the height, which is really cool. But we definitely want that width. So how do we do that? Well, if you look at the Rect Transform, if you've been paying really, really close attention, you may have noticed that the actual parameters of the Rect Transform change depending on our docking mode, which is also really cool because they make sense based on the context of what we're doing. So you'll notice that I now have this option for width. So for example, I can type in 200 and I now have it constrained to 200 pixels wide. Coming back here to the game view, you'll now notice that the panel behaves exactly like I expect it to. That's a really, really quick introduction to some of the things we can do with the Rect Transform. There's a whole lot more we can do with it, and we'll talk about that more in depth later. I do want to go ahead and introduce a couple of bits of padding though, because you'll notice that by default our panels use this really nice little rounded rectangle doohickey. Well, I don't like how that looks on the edge of the screen. I think it would look a lot better if we introduced some padding. We can do this visually, of course, by clicking on our panel and selecting the Rect Transform tool right here, which is a new addition in Unity 4.6. This can also be activated by hitting the Y key on your keyboard. And once we do that, we can adjust our padding however we want. Or, if we want to be a little bit more precise, we could also come over here to the Rect Transform. I can set its position 10 to negative, or position X to negative 10, its top to 10, and its bottom to 10. This gives us about 10 units of padding. But despite that padding, you'll notice that our previous behaviors of vertical stretching combined with horizontal stickiness to the right is preserved. Anyway, so that's really cool. We'll talk again more about Rect Transforms later. Next thing I want to go ahead and do is let's place a slider, because why not? Let's right-click Panel, because I want it to be a child of Panel. I'm going to click UI, and I'm going to create a slider. Now the behavior of the slider is I want the slider to stick to the top of this panel. Very easy way to do that is to open up our Rect Transform presets, hold down Alt and Shift, and click that button right there. Now, it is at the top of the panel. Furthermore, you'll notice that it sticks to the top of the panel. Just like with our panel, we can introduce some padding to it by specifying a left of 10, a right of 10, And how about a position of -10? By doing that, we have now successfully created some padding, and our behaviors are still as expected. All right, let's go ahead and talk about some interaction. Well, nah, let's do a button for it next. Let's do a button, and then we'll talk about interaction, because I want to show you guys how we can create a button and create a click handler for that button, because that's another thing I think is really important to understand. I hope you guys are so far kind of getting a feel for how the Rect Transforms work. So next up, I really want to show you guys how you could handle an event, because handling an event is really pretty much all UIs do besides presenting information. So on this panel right here, I'm going to add another child to it by right-clicking UI button. And this button, I want it to be at the bottom of the panel, and I want it to be stickied to the bottom of the panel. Now again, naively, I could do this, but if I did that, you'll notice it doesn't quite stick. It kind of like kind of moves as I resize vertically, which isn't the behavior I'm looking for. So I'm going to do just like we did with the slider. Open up this little Rect Transform helper, hold down Alt and Shift, and click down here to the bottom. Then I'm going to give it a padding of 10 by giving it a left of 10, a position, a Y of 10, a right of 10, and now we have that 10 units of padding, giving us very fine control over how we want this displayed. So let's say that when we click the button, we want this slider, the value of this slider, to be printed to our console. So it seems like a really straightforward thing to do, and I think it's a good example because A, it shows how we can handle a click event, B, it shows how we can extract the value of the slider, and then, well, really that's about all. But still, good stuff. So let's go ahead and get that worked out. So in the immediate mode GUI, handling a click event is pretty straightforward. You just type in if GUI.button, then do something. Well, in this system, it's a little bit more complex, but more simple at the same time, which is a really interesting way that they went about this. It's actually the way we can handle events in the new GUI system is ridiculously flexible. And it's very straightforward once you have seen an example of it being done. Basically, when we have our button right here, and we have the button selected in the hierarchy, remember, the button selected, not the text. It's very easy to accidentally select the text by double-clicking on the button, but make sure that you have the button selected. You'll notice that it has this button script attached to it. The button script has this onClick, which says list is empty. Basically, I can fill this list with things I want to have happen when the button is clicked. So what determines a thing that I want to have happen? Well, basically, any function that meets a particular criteria on any game object in the entire scene can be invoked by simply filling out this onClick list. So let's go ahead and do that. What I'm going to do is I'm going to create a mono behavior. I'm going to create a C# script, and I'm going to call this button test. And then I'm going to sync mono develop project. Wait a year or two. And then hope Visual Studio is going to open up properly, and it does. Okay, so our button test is basically going to be a game object that'll be responsible for responding to a click event from the button that we've placed in our scene. But again, I did say earlier that I wanted it to take the value of the slider and print it out to the console. So our button test is going to need a reference to our slider. It's very simple to do. We'll just type in public slider, and now you'll notice that autocomplete actually doesn't show you anything. The reason it doesn't is because most of the objects or the classes that we're going to be dealing with when working in the new GUI system are going to be located in the Unity Engine.UI namespace. So Unity is finally embracing the concept that you can have multiple namespaces, which is cool. But it'll also require everybody wanting to work with the UI and code to add a using statement up at the top of the file of using Unity Engine.UI. So make sure you have that. Okay, so now that we have our public slider field, I'm going to name it. I'll just name it slider because I'm not a very creative person. So now what do we have to do? Well, again, I want this button to be notified when the button in our scene view is clicked. So basically what we have to do is we have to create a method that follows a particular criteria. The method must be public. The method must return void. It can be named anything. And it must take in 0 to 1 parameters. So let's just leave it as 0 parameters. Now what I'm going to do is I'm going to say debug.log slider.value.toString. So do something, we'll simply debug log slider value toString. Because this method is public and it's void and it takes 0 parameters, I can use this as a target for my button click. So jumping back into Unity, let's go ahead and do just that. The first thing I need to do is actually instantiate my button test component somewhere in the scene. So what I can do is I can come over here to my hierarchy. I can right click and I can say create empty. And then I'm going to call this button responder. Now the button responder game object, I'm going to add a button test component to. So I'm going to take button test, I'm going to click and drag it over into the inspector. Now remember, our button responder does need a reference to our slider component, which is this guy right up here. So to do that, I'm going to go back to the button responder game object. I'm going to take the slider over here in our hierarchy, and I'm going to click and drag it into the slider property of our button test script. And then once I drop it there, it's associated. So that's really all the setup we need, because now we have a target for the button to invoke. So I'm going to click on the button. I'm going to scroll down to the on click list. I'm going to hit plus, and you'll notice that this line item appeared. And it's going to have these 4 things on it, 4 pieces of data. Whether or not it's enabled, what's the target game object, what's the target function, and what parameter to pass to it, if any. So the first question is, what's the target game object? Well, if we click on this little circly guy here, we can select our button responder. Well, in fact, we could select anything we wanted, but in this case, we're selecting our button responder. Now we have to select a function. So we click on this little drop down, and we're going to see it organized by component. So each component is going to get its own little drop down menu. We're going to want to select the button test component, and now we can select any one of these values. The one we're going to want to select is the do something method. And that's it. Our button, when now clicked, will invoke the do something method on the button responder object. Let's test that out. I'm going to go ahead and hit play, then I'm going to hit the button, and we get 1 printed out. Let's move the slider down a little bit, and we get a fractional value, and we get 0, and we get another about halfway-ish, and so on, and so on. All right, I do want to point out one quick thing that we could also do in addition to what we did with the on-click. I don't want to get too in-depth with event handling because we have a whole video about that coming up, but for now, I just want to show you something else that's really cool. I'm going to delete that handler. I'm going to go back into code, and up here on my my button test, I'm going to create another method. I'm going to say public void do something with a slider. And then I'm going to just print out slider value toString. Note that I'm doing the lowercase slider, which is provided to me as a parameter, and not the uppercase slider field. So I just want to demonstrate one other really cool thing about hooking up events in the new GUI system. You'll notice in our previous example, we had the slider reference actually added from within the inspector. But what if we wanted to provide the slider as a parameter? Well, we can actually do that with the new GUI system. The GUI system can, like I said, accept events or methods as events if they have 0 to 1 parameters, and if that parameter is a game object, or rather an object, a string, an int, a bool, a float, and a couple other I'm probably forgetting, basically primitive types. So now that we've created this method, let's jump back into Unity and come over here to our button and hit Add. Drag over our button responder. Click on the No function, open up Button Test, go down to Do Something with a Slider, and now you'll notice that we can now fill in the parameter. What's the parameter that we're going to want to fill it in with? Well, it's the slider object that we already created in the panel. So coming over here to our hierarchy and clicking and dragging the slider over into this little parameter or argument doohickey right here, dropping it there, will actually provide that as a parameter to the function when it's invoked. So now what I can do is I can hit play and I'll get the exact same behavior, although we didn't statically provide the slider to the button responder, we provided it as a parameter. All right, there's two more things I want to show you guys before we'll head off into some more in-depth discussions. And that is a really powerful new cool ability with images and how to hook up slider values to other values. So let's look at images first. I'm going to go in here into my panel. I'm going to right click, create new UI. I'm going to create an image. Now this image I'm going to leave in the center of the screen. I'm not going to worry about positioning it. Then we're going to go over here to the image component on the image game object, and on the source image I'm going to click this little circly doohickey, and I'll select one of our built-in source images, like a check mark. Okay, so that's really cool so far. We can add images to it. Actually, that's not particularly exciting. But still, it can be really cool because the images now support the concept of this image type. We'll talk about the other image types later, but for now, let's just talk about the sliced one because I find this particularly interesting. If we click on sliced, or whoops, not sliced, filled. Derp to derp. All right, if we click on filled, we can actually use this fill amount property that appears to determine how much of the image is filled. I don't know, when I was learning the whole new GUI system, this is one of my favorite things because it makes things all really easy to put together. For example, we could use this to put together a speedometer. Or if we change the fill method to horizontal, we can use this as a health bar. So that was just something that particularly made me happy when I saw it. Lots of fun stuff. So we have our fill amount, and that's really cool. But another interesting thing we can show here before signing off is the ability for the slider to actually send events. So if I click on the slider, you'll notice if I scroll down that he has an on value changed. And you'll notice this little parenthesis, single parenthesis. That means that this on value changed needs to accept a method that takes in a float and won't accept anything else. Well, it will if it's a parameterless. So let's go ahead and click the Add button. And what I'm going to do is I'm going to take this image right here. This is the image that I have selected right here in the hierarchy. And I'm going to click and drag it over into the target object of the on value changed. Then for the function, I'm going to select image. Then on dynamic float, I'm going to select fill amount. So now I'm going to hit run, and you'll notice as I change the slider, the fill amount also changes. In fact, I can see that represented in the inspector as well. If I click on the image over here in my hierarchy and look at the inspector and watch the fill amount as I change my slider, you'll notice it changing. All right. Well, anyway, this was really just a quick rundown of the GUI system. I really wanted to show you guys how to start using it by creating a canvas, and I wanted to show you guys how to dock panels and how to create some basic interaction. So, this sort of thing should get you guys up and running relatively quickly, but there's a whole lot more that we need to discuss, and we're going to do that in a little bit more in depth here shortly. All right, guys, we'll see you in the next video.